I'll just summarize.
Okay. It's hard to see anyway. If the reactants have 50 kilojoules and the products have 25 kilojoules, so as this progresses, it releases negative 20. It releases 25. But we say it's negative because it dropped negative, right? It dropped. It went in the negative there. It lost 25. Who remembers? Exo or endo if it's a negative value for delta H?
Endo. No, exo.
Exo negative? You sure about that? Exit. Leaves, right. Exo means negative, right. So that is correct. Exothermic. So anyways, that's energy of reactants is 4, energy of products number 5. Now, while we're here, what number tells me the difference in energy? What's the difference between 50 and 25? What number marks that segment? 3. Between 50 and 25 here. What number is in between here and here? 3. What's 3 called? Delta H. That's the heat of reaction. That's what the heat of reaction is for this reaction. If we were to label 50 and 25, our heat of reaction, how much heat it either gives off or absorbs, would be negative 25. That's the delta H. It's always between your reactants and products. Okay, I'll do 6 later. I'm going to erase this though because I got to scroll down because I want the number 2 to be on the board up here. All right, and what I'm going to do actually today at the end of class is show you a demo that kind of helps you understand a little bit about this. All right, okay, so number 1, Devin, I already called on Devin today. Steph, what's number 1?
Activation energy of forward reaction.
Good, activation energy, AE, of the forward reaction. Forward reaction, in other words, going that direction, from reactants to products. That's our, you know what? I don't like this. Hold on. I want to be able to see the bottom here.
Just draw your own line.
Well, I wanted to just copy exactly what you had. That's good. Okay, so this is the activation energy of the forward reaction. So starting here, going through over the bump here, over the hill, down to products. That's your forward. All right, what about number 2? Zach, what's 2? Say it again.
Activation complex.
Close, yeah. Activated complex. Activated complex is at the top. Yesterday's video. 2 things necessary for a reaction to occur. Shelby, what's one of them? 2 things that need to happen for a reaction to occur from the video yesterday. To get a fruitful collision. Good. Sufficient kinetic energy. They got to be hitting each other hard enough. Good. Sarah, what's the other one? 2 things that has to happen for a reaction to occur. Particles have to hit each other hard enough, and from the video yesterday. The key analogy. Chuck, help her out. 2 things that has to happen for a reaction to occur. Proper energy, so they collide.
Alignment.
And alignment, orientation. Very good. That's what happens right up at the top here, right here. The reacting particles, let's say you have 2 particles that want to collide, they need to gain enough energy so when they collide at the top, they can actually form products. So activated complex is where those collisions are occurring. And if it's effective or fruitful, it makes products. If not, it falls back down and it doesn't react. Okay, number 6. This one is the activation energy, but Blake? Number 6?
I get it.
Jake? Oh, you worked with Blake. Edmund? It was labeled in the review book, was it not?
No.
It was. Yes, it was. Yes, with a catalyst. With a catalyst. Number 6 is activation energy with a catalyst. Number 1 is activation energy of the forward without a catalyst. So let me explain this very clearly. So if you're daydreaming, knock it off. Pay attention. So if you look at number 1, okay, and then look at number 6, there's a big difference. So let's say Zach is standing right here. I gotta give him this little hat here.
You know, get the ball on the top.
That doesn't look very good, but that's your hat. Okay.
This
All right.
also looked like a dump on his head.
Okay. So there's Zach. He wants to get here. He has two paths he can take. He can go up the top hill and then down, or he can go the bottom hill and go down. So if Zach was in a hurry, which one would probably be a quicker path?
The
Zach?
top one.
Bottom one, right. So the bottom path is easier for Zach to get to the products because he doesn't have to climb as high. In reaction world, chemistry world here, it's the same thing. So when you add a catalyst, what it does is speeds up a reaction, reacts faster. This is why. It gives an alternate pathway to get to the products. So you could go all the way to the top and then form products, but that would take longer than it would going in the bottom one here. So reactants do the same thing. They take the easy way if it's provided. If there's another alternate pathway, then they will do their little collision right at the top of here, and they'll form products. That's what a catalyst does. That's what a catalyst does. All right? It lowers that activation energy, and I'll talk more about that in a little bit. Number 8, activation energy of the reverse, and that's without a catalyst. You're using the top peak. That's without the catalyst. Number 7, activation energy of the reverse with a catalyst. So number 7 is the reverse reaction's activation energy. So activation energy can work both ways. Forward, going to products, or in reverse, going to reactants. So again, 8 is activation energy of the reverse without a catalyst, and then 7 is with a catalyst. So again, you're going from the products up to reactants. You're using the lower peak. So hopefully you got all of them labeled correctly. We will go over that again today, tomorrow. I don't know if I have time to squeeze in the demo. We can try real quick. Hold on, don't pack it up yet. Activation energy, I'm just going to define number 1 really quick, is the energy needed to start a reaction. It's the energy needed to start a reaction. So if you give a reaction energy, it will reach the activation energy faster. So activation energy, number 1, is the energy required to start a reaction. I'm going to write all this down tomorrow. I just don't have time. I don't know. You want to try and squeeze it in? Mm-hmm. Yeah, come on back. It reacts very quickly. So.